Hello students, welcome back. In this video we are going to discuss about some more problems in fiber optics. So our first problem is a step index fiber has a core refractive index 1.50 and a cladding of refractive index 1.40. If the fiber is used in a water environment, find the numerical aperture and the acceptance angle. Take the refractive index of water as 1.33. So let us see the given parameters. The given parameters are the refractive index of the core, that is N1 is 1.50, refractive index of the cladding, that is N2 is 1.40, and the refractive index of the launching medium. The launching medium here is water. So we have taken the refractive index N as 1.33. So according to the problem, we have to find out the numerical aperture. We have seen that the numerical aperture is given as sine of theta A, where theta A is the acceptance angle. So it is n1 square minus n2 square whole over root divided by n. So let us put the value of n1, n2 and n, that is 1.5 square minus 1.4 square divided by 1.33, which is equal to 0.538 divided by 1.33. So sin theta A is coming as 0.404. Here we also need to find out the acceptance angle. So the acceptance angle is theta A, which is equal to sine inverse 0.404, which is equal to 23.8. So the acceptance angle is 23.8. Let us move to our next problem. Our next problem is calculate the fractional index change for a given optical fiber if the refractive indices of the core and the cladding are 1.572 and 1.498 respectively. So how do we define the fractional index change? Fractional index change is defined as, we take it as del, it is defined as n1 minus n2 by n1, where n1 is the refractive index of the core, n2 is the refractive index of the cladding. So it is 1.572 minus 1.498 divided by 1.572. So it comes as 0.047. So fractional index change is here in this problem is 0.047. Now let us move to our next problem. Our next problem is the numerical aperture and the fractional refractive index of an optical fiber are 0.24 and 0.012 respectively. Find the refractive indices of the core and the cladding. The given parameters are numerical aperture, which is equal to 0.24, and del, that is the fractional refractive index, that is 0.012. So what we need to find out? N1 and N2. N1 is the refractive index of the core, N2 is the refractive index of the cladding. So if you follow the theory, Na, that is the numerical aperture, is given as N1 root over of 2 del. Na, that is the numerical aperture, is given here as 0.24 is equal to N1, that we need to find out, is root over of 2 into 0.012, which is equal to 0.155 N1. Now N1 is equal to 0.24 divided by 0.155, that is equal to 1.55. So the refractive index of the core is 1.55. Here in the problem, the fractional refractive index is given as del, that is n1 minus n2 by n1, is equal to, n1 we have already found out, that is equal to 1.55 minus n2 by 1.55, and del is 0.012. So from this equation, if we solve it, we get the value of n2. So we write the equation, that is 1.55 minus 0.186 is equal to 1.53. So the refractive index of the core we get as 1.55 and the refractive index of the cladding is 1.53. So these are the answer of this problem number 6. Now let us move to our last problem here. Let me read it out. A step index fiber has a core of diameter 30 micrometer, refractive index 1.52 and fractional refractive index difference of 0.0007. It is operated on a wavelength of 1.4 micrometer. Find the normalized frequency or the V number of the fiber and the number of modes the fiber support. So the given parameters here, the diameter of the core, let us take it as D, which is equal to 30 micrometer. 30 micrometer means 30 into 10 to the power minus 6 meter. Refractive index of the core is given as 1.52. The fractional refractive index changes, that is del, is 0.0007. Lambda is 1.4 micrometer, which is equal to 1.4 into 10 to the power minus 6 meter. Now what we need to find out is the normalized frequency or the V number. V number is given as, basically we defined V number as pi d by lambda root over of n1 square minus n2 square, where d is the diameter of the core, lambda is the wavelength, n1 is the refractive index of the core, n2 is the refractive index of the cladding. So we can write here, you can see the numerical aperture, we can write as root over of n1 square minus n2 square, we can write it as numerical aperture. So pi d into na is equal to pi d by lambda n1 root over 2 del. So let us put all the values here. 3.14 into value of d, 30 into 10 to the power minus 6, the value of lambda 1.4 into 10 to the power minus 6, which is multiplied by n1. N1 is given as 1.52 and twice of del is 0.0007. So after putting all the values, we get the V number as 3.82. So basically V number gives the normalized frequency. And if we need to find out the number of modes, it is in case of step index fiber, it is V square by 2. So putting the value of V, squaring it and dividing it by 2, we get the number of modes as 7.32, which is equal to 7 modes.